Hello everyone, very warm welcome to Venkat Varma Chemistry YouTube channel. I hope all are doing well. In this session, I am going to discuss basic organic chemistry. Basic organic chemistry. See, first of all, what is organic chemistry? What is organic chemistry? See, the first scientist Berzelius in 1815, the scientist Berzelius in 1815 proposed the vital force was responsible for formation of organic compound. See, the scientist Berzelius, he was proposed that vital force was responsible for formation of organic compound. Formation of organic compound. See, he says that organic compounds only extracted from living organisms like plants and animals. After few years, 1828, Euler synthesized first organic compound urea from inorganic compound. See, the name of scientist is Euler. He was synthesized the first organic compound. Urea from inorganic compound. Urea from inorganic compound. See, urea from inorganic compound. The name of compound is ammonium cyanate. See, he was prepared ammonium cyanate heated to prepare urea in lab from inorganic compound. See, it is a ammonium cyanate. Urea is a organic compound. Ammonium cyanate is a inorganic compound. See, then after that, the vital force was disproved when the Euler prepared organic compound from inorganic compound. The VFT theory, vital force theory, was disproved by Euler. The next scientist in 1845, the scientist Kolbe's synthesized organic compound from its elements. The name of organic compound is acetic acid. Kolbe's synthesized acetic acid from its elements. As now, the scientist Berthollet, he was synthesized methane from its elements. So, what is organic chemistry? Organic chemistry is the study of hydrocarbon, their derivatives. See, organic compound is a, or organic chemistry is the study of hydrocarbons and their derivatives. Let's move on. Characteristics of carbon. carbon. See, have a look for characteristics of carbon. See, characteristics of carbon atoms. Characteristics of carbon atom. See, generally carbon shows tetravalency. See, carbon shows tetravalency. Carbon shows tetravalency. See, the ability of carbon atom to form 4 bonds is known as tetravalency. What is mean by tetravalency? The ability of carbon atom, the ability of carbon atom to form 4 bonds, 4 bonds is known as tetravalency. Tetravalency. What is mean by tetravalency? The ability of carbon atom to form 4 bonds is known as tetravalency. Tetravalency. See, to exhibit tetravalency of carbon form, see, to exhibit tetravalency of carbon atom, see, all 4 single bonds, all 4 single bonds, 2 double bonds, or 1 double bond, 2 single bond. See, 1 double bond and 2 single bond. 1 triple bond, 1 single bond. See, 1 triple bond and 1 single bond. See, to exhibit tetravalency of carbon atom, then all 4 single bonds, 2 double bond, 1 double bond, 2 single bond, 1 triple bond, 1 single bond. See, I will look for why the carbon shows tetravalency. Why the carbon shows tetravalency. See, I will look for this. Generally, the carbon, its atomic number 6. Yes, carbon atomic number 6. What is electronic configuration of the carbon? 1s2, 2s2, 2p2. See, carbon, the ground state of electronic configuration of carbon atom, it is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. This is for ground state configuration of electronic configuration of the carbon. Have a look for excited state of electronic configuration of carbon atom. It is see, 1s2, see, 2s1, it is a 2px1, 2py1 and 2pz1. See, it is a 2s1, see, 2s1, 2px1, 2py1, 2pz1. See, available for bond formation, it shows tetravalency. Need excitation of energy. For excitation energy required, see, for excitation energy required. Its value is 501.6 kilojoules per mole. Kilojoules per mole. See, this is a carbon shows tetravalency. Carbon shows tetravalency. See, we will look for next term. So first of all, we need some basic terms to understand the hybridization. See, what is a sigma bond and what is pi bond? What is sigma bond? See, have a look for what is sigma bond. See, what is sigma and pi bond? Sigma and pi bond. See, sigma bond formed by the linear overlapping of atomic orbitals. See, sigma bond is formed by linear overlapping of atomic orbitals. See, for example, it is s orbital overlapping with s orbital. See, to form a sigma bond. It is a linear overlapping. To form a sigma bond. Have a look for next one. It is s orbital and s orbital to form a sigma bond. See, have a look for s orbital and p orbital. Linear overlapping. It is also form sigma bond. What is sigma bond? Sigma bond is formed by, see, sigma bond is formed by linear overlapping. See, linear overlapping of atomic orbitals or hybrid orbitals. Overlapping is the sigma bond. What is pi bond? See, pi bond is formed by lateral overlapping. See, lateral overlapping of pure atomic orbitals. Pure atomic orbitals are sidewise overlapping of atomic orbitals can form pi bond. See, we are taking pure orbital. See, I am taking pure orbitals. See, overlapping of sidewise overlapping. See, have a look for. See, it is a pure p orbital. Have a look for pure p orbital. I am taking pure p orbital. So it can form linear overlapping means sigma is formed. Pure orbital sidewise overlapping to form a pi bond. See, sigma bond is stronger than pi bond. Yes or no? So sigma bond is stronger than pi bond. Yes or no? Already we know sigma bond is stronger than pi bond. See, pi bond is more reactive. Pi bond is more reactive than sigma bond. Pi bond is more reactive than sigma bond. See, have a look for next. See, the next term is a tendency to form multiple bond. The next character is a tendency to form multiple bond. See, the first character is a tetravalency. The second character is a tendency to form multiple bond. Tendency to form multiple bond. What is mean by multiple bond? Double and triple bond. See, the carbon atom can form following type of bond. See, carbon atom can form following types. See, carbon-carbon single bond, carbon-carbon single bond, and carbon-carbon double bond, carbon-carbon double bond, and carbon-carbon triple bond. See, carbon can form these type of bond. Yes or no? Carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond. See, carbon-carbon double bond. This is a tendency to form multiple bond. Tendency to form multiple bond. See, have a look for the next character. Have a look for next character. See, tetrahedral shape. See, the next character is a tetrahedral shape. See, tetrahedral shape. Tetrahedral shape. See, what it mean by tetrahedral shape? What it means? Tetrahedral shape. See, the four covalent bonds are directed towards the four corners of a regular tetrahedron. See, carbon. See, carbon. The four covalent bonds. See, the four covalent bonds are directed towards the four corners. Directed towards the four corners. Directed towards the four corners. Regular tetrahedron manner. Regular tetrahedron manner. Its hybridization is sp3 hybridization. Its hybridization is sp3 hybridization. Its bond angle is 109 degrees to 8 minutes. 109 degrees to 8 minutes. This is about tetrahedral shape. Tetrahedral shape. Have a look for the next character. The next character, go for catenation. Go for catenation. See, catenation. What is mean by catenation? What is mean by catenation? Yes, the self-linking property of carbon atom is known as, see, self-linking, the self-linking property of carbon atom, property of carbon atom is known as catenation. Is known as catenation. Yes, or one more definition also. The ability of carbon atom to form long chains, rings is known as catenation. Yes, see, ability of carbon atom to form long chains, or rings is known as catenation. See, catenation, it is responsible for the variety of large number of organic compounds. It may be give rise to open chain and closed chain of compounds. See, carbon can form the ability of long chains, rings. See, like that. If the carbon-carbon single bond, carbon-carbon triple bond, carbon-carbon double bond, also carbon-carbon double bond. See, this is a way of ability to form rings or chains. Rings or chains. See, is the catenation property. The most catenation property in periodic table is a carbon, after that silicon. After that silicon. See, have a look for next. Move for next. See. See, if structure, it is a structure, okay, and number of sigma and pi bonds, number of sigma and pi bonds. After that hybridization, then bond angle, after that shape, See, the first one, structure, carbon carbon single bond. See, carbon carbon single bond. How many sigma bonds? See, the single line means sigma bond. See, sigma sigma sigma. How many sigmas? 4 sigmas. How many pi? No pi. No pi. 4 sigma bonds. 0 pi bonds. It shows sp3 hybridization. If the carbon has 4 sigma bonds, it shows sp3 hybridization. Its bond angle is 109 degrees to 8 minutes. Its shape is tetrahedral. Its shape is tetrahedral. See, have a look for next. Carbon with double bond. See, how many sigma bonds? Sigma, sigma, sigma. Now 1 pi bond. See, 3 sigma and 1 pi. So this carbon has all sigma bonds. Yes, this carbon has 3 sigma, 1 pi. It undergoes sp2 hybridization. sp2 hybridization. So its bond angle is 120 degrees. Its shape is trigonal planar. Trigonal planar. Is a trigonal planar. See, have a look for next. Carbon having sigma sigma and 2 pi. See, 2 sigma 2 pi. It undergoes sp hybridization. Its bond angle is 180 degrees. Its shape is linear. Its shape is linear. See, 2 sigma and 2 pi. Have a look for next one. See, have a look for next one. See, here 2 sigmas 2 pi. 2 sigmas 2 pi means its hybridization is sp. Its bond angle is 180 degrees. Its shape is linear. Its shape is linear. See, this is about structure and number of sigma bonds and hybridization and bond angle and shape. See, have a look for next one. We can do some examples for the hybridization. See, have a look for this. See, generally, how to find hybridization? Hybridization is found. It is using steric number. It is use steric number. What it means steric number? Number of sigma bond plus number of lone pair. Yes or no? Number of sigma bond plus number of lone pairs. Number of lone pairs, we can find hybridization. Yes or no? We can find hybridization. Have a look for next one. CH3 plus. CH3 plus. Carbon having, see, how many sigmas? 1, 2, 3, 3 sigma. 3 sigma means what is a hybridization? Obviously sp2. sp2. Yes. See, next CH3 minus. CH3 minus. Have a look for structure. See, H. It is a CH3 minus means it is a one lone pair. See, it has 3 sigma plus 1 lone pair. It is a 4. 3 sigmas, 1 lone pair. Steric number is a 4. It undergoes sp3 hybridization. sp3 hybridization. Very simple to finding the hybridization. 4 sigma means sp3. Okay. 3 sigma means sp2. 2 sigma means sp. This is the finding of hybridization very easily. 4 sigma sp3, 3 sigma sp2, 2 sigma sp, 2 sigma sp. See, I will look for of identify the hybridization of each carbon atom. Each carbon atom. I will look for, see, identify the, see, identify the hybridization of each carbon atoms. Each carbon atoms. I will look for example. I will look for example. See, I am writing bond line structure. I am writing bond line structure. See, see, it is a single bond, single bond, single bond, single bond. It is a double bond. It is a double bond. See, single bond means what? It is a carbon. It has 3 hydrogen. Yes or no? So it has 4 sigmas means sp3. It has 2 hydrogens. It is also sp3. Yes or no? It is also sp3 hybridization. It is also sp3 hybridization. Have a look for this. Carbon double bond means 3 sigmas. 3 sigma 1 pi. 3 sigma 1 pi. It undergoes sp2. Yes or no? Same as 3 sigma, 1 sigma, say 1 sigma, 2 sigma, 3 sigma, 1 pi. It is undergoes sp2 hybridization. sp2 hybridization. I will look for next example. Say, yes, see, single bond means sp3, sp3 single bond. It is sp3. It is also sp3 double bond sp2, sp2. See, I will look for example. See, look at this example. Look at this example. See, carbon having triple bond means sp. Triple bond means sp. Yes. Double bond means all these carbons are undergoes sp2 hybridization, sp2 hybridization, sp2 hybridization, sp2 hybridization, sp2 hybridization, and sp2 hybridization. Yes. See, I will look for one more example. See, I will look for one more example. See, what hybridization? It is sp3. Yes, it is also sp3. It is a sp3. It is a sp2. It is a sp2. Yes or no? It is a sp3. It is a sp. It is also sp. Yes, it is sp3. It is also sp3 hybridization. sp3 hybridization. So these are the example for the finding of or identify the hybridization of each carbon. Hybridization of each carbon. See, I will look for the next term, electronegativity of hybrid orbitals. See, it is a very important for the further content. Okay, see, electronegativity of hybrid orbitals. See, electronegativity of hybrid orbitals. Electronegativity of hybrid orbitals. See, first of all, what is meant by electronegativity? The tendency to attract the electron pair is electronegativity. See, in electronegativity, percentage of the S character is increases, electronegativity also increases. Percentage of the S character is increases, electronegativity is increases. What it means? Electronegativity is directly proportional to S character. Yes or no? Electronegativity is directly proportional to S character. See how to calculate percentage of the S character. Have a look for how to calculate percentage of the S character. See, have a look for percentage of the S character equal to, so S orbital divided by total number of orbitals into 100 into 100. Have a look for example, sp hybridization is there. Let's find percentage of the s character in sp hybridization. See, s orbital, how many number of s orbital? 1. Total number of orbital? 1 s orbital, 1 p orbital, means 2 into 100. It becomes what? 50 percentage. sp has 50 percentage of the s character. Have a look for sp2 hybridization. Percentage of the s character equal to 1 s orbital, total number of orbitals are 3 into 100. It becomes 33.3 percentage. Yes. Have a look for sp3. Percentage of the s character equal to 1 s orbital, total is 4 into 100. It becomes 75 percentage. It becomes 75 percentage of the S character. Sorry, 25 percentage. It is a 25 percentage of the S character. The P is a 75. P percentage is a 75. Yes. See, I will look for percentage of the S character in SP is a 50 percentage, in SP2 33.3, and SP3 is a 25 percentage. Generally, electronegativity of SP is greater than SP2 is greater than SP3. See, this is for electronegativity for hybrid orbital. Electronegativity for hybrid orbitals. Electronegativity for hybrid orbitals. See. Yes. Now, one more important point. See, electronegativity, order of electronegativity. The fluorine is most electronegativity in the periodic table. After that, oxygen. After that, carbon sp hybrid orbital. And after that, nitrogen. After that, carbon sp2. After that, carbon sp3 hybridization. Carbon sp3 hybridization. Yes. Have a look for bond strength is directly proportional to electronegativity. Bond strength is directly proportional to electronegativity. Bond strength is inversely proportional to bond length. Bond strength is inversely proportional to bond length, and bond length is inversely proportional to electronegativity. See, bond strength is directly proportional to electronegativity. Bond strength is inversely proportional to bond length, and bond length is inversely proportional to electronegativity. Have a look for this one. See. See, arrange the following increasing order of the bond length. See, arrange following increasing order of bond length. Bond length is inversely proportional to electronegativity. For example, I am taking C H triple bond CH, okay, and CH3, okay, and CH2 double bond CH2. CH2. See, I'm taking this is the X, yes, this is Y, this is Z, this is Z. See, generally what bond length is inversely proportional to electronegativity. According to this, which is more, which is more, so which is less electronegativity, that is a more. So what is Z? Is greater than, sorry, Y is greater than, Z is greater than X. Yes, this is our answer. I will look for next question. I will look for next question. See, C triple bond CH, CH3, CH2, H, and CH2 double bond CH, H. See, it is a A, it is a B, it is a C. So what is a increasing order of bond length? So it undergoes SP, it is a SP3, it is a SP2. So which is B? For example, it is a B is greater than, C is greater than A. Okay, C. This is the increasing order of the bond length. Increasing order of the bond length in carbon compounds. Carbon compounds. See, I will look for finding the or calculation of sigma and pi bonds and lone pairs. I will look for calculation of, see, calculation of sigma, pi, and lone pairs in following compound. For example, I am taking a simple example. For example, A single bond with B, A double bond with B, A triple bond with B. Okay, so single bond means it is a sigma. Double bond means 1 sigma, 1 pi. Triple bond means 1 sigma, 2 pi. 1 sigma, 2 pi bonds. 2 pi bonds. See, finding the number of sigma and pi bond in following compound. See, I will look for one example. I am taking simple example. See, CH3, okay, CH2, CH2OH. Okay, hydrogen also considered as one sigma bond. One sigma bond. So now count the sigma bond. See, hydrogen 1, yes, it is 2, 3, 4, okay, 5, 6, 7, 8, and 9, 10, 11. So it has 11 sigma bond. 11 sigma bond. There is no pi bond. Yes or no? No pi bond. No pi bond. See, 1 sigma. See, 2, 3, 4. Okay, 5, 6, 7, 8, 9, 10, 11. I will look for next example. See, look at for example. See, CH3, CH2, CH double bond CH2OH. CH2OH. Now count the sigma bond. See, it is 1. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 3. It is a 13 sigma bond. 13 sigma bond and 1 pi bond. 1 pi bond. 13 sigma bond, 1 pi bond. 13 sigma bond and 1 pi bond. See, I will look for next question. It is a previous question. Okay, see, previous question. CH2 double bond CH, C triple bond CH. Okay, see, count the sigma bond. See, 1 sigma, 2, 3, 4, 5, 6, 7. So 7 sigma. How many pi bond? Here 2 pi bonds and 1 pi bond. Total number of pi bonds 3 pi bond. 3 pi bond. So next question. This is also previous question. Previous question from mains. Okay. See, HC triple bond CH2 C triple bond CH3. Count the sigma bond. 3, 4, 5, 6, 7, 8, 9, 10 and 11. It has 11 sigma bond and 4 pi bond. 11 sigma bond and 4 pi bond. Yes or no? I will look for next question. This is also previous question in AIIMS. CH2 double bond CH and CH2CN. This question is a AIIMS. CH2 double bond CH2CN. See, CN means it has triple bond, 1 sigma, 2, but nitrogen, carbon with nitrogen. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigmas. See, how many pi bonds? 1 and carbon with nitrogen is 2. The total is 3 pi. The name of compound is, it is allyl cyanide. It is the allyl cyanide. Allyl cyanide contain 9 sigma 3 pi bond. 9 sigma 3 pi bond. I will look for next question. Toluene. It is also previous question in mains. Okay. I will look for the toluene structure. See, I will look for a toluene structure. This is a toluene structure. Yes, benzene with CH3. Benzene with CH3. So it means what? It has one hydrogen. It has one hydrogen. It has one hydrogen. It is one hydrogen. One hydrogen. See, count the sigma bond. So 3. Okay. Hydrogen means 1 sigma. 3 hydrogen means 3 sigma. Okay. 3, 4, 5, 6, 7, 8. Yes, 8 over, and each carbon has sigma 14. Okay, 14 and this 15 sigmas. How many pi's? 1, 2, 3 pi's. 3 pi's. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 sigma bond, 3 pi bond. Okay. So I will look for next question. See, styrene. It is also previous question. See, styrene. Benzene with CH double bond CH2. See, here also hydrogen is there, hydrogen is there, hydrogen is there, hydrogen is there, hydrogen is there. Yes. So 2 hydrogens means 2 sigma bond. 1 hydrogen means 1 sigma bond. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, 10, and every carbon has 1 sigma bond. Means this is a 6, means 16 sigma bond. And how many pi bonds? 1, 2, 3, 4. 4 pi bond. 4 pi bonds. 16 sigma, 4 pi bonds. 16 sigma bond and 4 pi bonds. Okay. Have a look for finding the number of lone pairs. It is finding the number of lone pairs. Finding the number of lone pairs. See, have a look for finding the number of lone pairs. Finding the number of lone pairs. See, I am taking one example. See, I will look for example. I will look for example. So finding of lone pair. So oxygen, this is oxygen. Oxygen has, see here 2 electrons is there. Oxygen belongs to 16 group. Okay, 16 group means how many valence electrons? 6. Here 2 over the remaining what? 1 and 1, 2, 3, 4, 5, 6. So how many lone pairs? 2 lone pairs of oxygen. Oxygen for 2 lone pairs. Have a look for nitrogen. See nitrogen, see 1, 2, 3. Already fill the 3 electron. Nitrogen, it belongs to 15th group, means 5. So it has 1 lone pair. So 1, 2, 3 and 4, 5. 1 lone pair. 2 lone pairs of oxygen, 1 lone pair of nitrogen. The total is the 3 lone pairs. 3 lone pair. Yes or no? Yes. Have a look for second example. See. So this is example. So same oxygen has how many lone pairs? So 2 over the remaining 6. 2 lone pairs. Here also. So total number is a 4 lone pairs. 4 lone pairs. Yes. Okay. See, have a look for how many carbon atoms are linearly arranged. See, this is a question. How many carbon atoms linearly arranged. Have a look for example. It is a CH3, C triple bond C and a CH double bond CH2. Finding the number of carbon atoms linearly arranged. So have a look for structure. Carbon triple bond C, yes, C double bond, it is H and carbon. So it has, this is the complete structure of carbon. So this carbon undergoes what hybridization? sp hybridization. This carbon is a sp, its bond angle is 180 degrees. 180. This carbon and this carbon shows sp hybridization. Yes, and here also bond angle is, 180 degrees. 180 degrees. So number of carbon atoms, linearly arranged. So it undergoes sp2, its bond angle is 120. Yes or no? 120. Say how many carbon atoms are linearly arranged? Have a look for. So it is 180. This carbon and up to here they are linearly arranged. Yes or no? It is sp2 hybridization. It is a bond angle 120. So number of carbon atoms 1, 2, 3, 4. So 4 carbon atoms. 4 carbon atoms. Yes or no? Have a look for next question. How many atoms are? How many total number of atoms are? See how many atoms are arranged linearly. See, have a look for CH triple bond CH. Yes, see, it is a HC triple bond CH. So it is a SP, it is SP, its bond angle is 180 degrees, its bond angle is 180 degrees. How many atoms are arranged in linearly? They are asking atoms. Atoms means 1, 2, 3, 4. Yes or no? See. One atom, two, three, four. Answer is four. Answer is four atoms. Answer is four atoms. So this is about finding of number of sigma and pi bonds and their hybridization. Their hybridization. Yes. See. I hope like this video. Don't forget to share your friends. Don't forget to give like, subscribe to our channel and hit the bell icon to stay updated with the latest videos and notifications. Thanks for watching.